You are welcome to the GMAETS 41's live stream class on chemistry practical, right? This video is going to cover Chem 107 for students in UNIZIC. So I'm using this opportunity to welcome you once again to this class. All right. So what I've got for you, it's a way of trying to prepare you for your examination, which is kicking off today. Although in our physical class, we've actually dealt with questions already regarding this. But I thought it wise holding a live section class on it. All right, so we'll be kicking off with titration part. We're looking at titration part. If you can hear me, please indicate by typing. If you join the class, just type "I can hear you" so that I kick off. I'm going to dictate the question and then try to follow up, okay? You can copy the question and then we solve what is expected of us to do. So please, if you've joined the class, I can see friends joining. If you can hear me, please indicate "I can hear you." All right, Favor, thank you very much for indicating. So I think the GMAETS 41 is set to go. First of all, when preparing for your Chem 107, chemistry practical generally, you know, they have at almost the same principle that guides them, okay? And there are various areas you want to prepare for because your examiner does not respect any batch. What do I mean by that? You enter exam hall, you give your question paper, whatever you see, you answer. But this is it, right? First things first. Your exam questions definitely in the aspect of titration, because you'll be tested on titration, volumetric analysis, you'll be tested on qualitative analysis, that is salt analysis. So the first thing is for you to be able to remember necessary principles guiding this. We are going to start with titration, like I said. I've got these exam questions we're going to look at. Under titration, there are about 3-4 aspects that you will be tested on. Any batch can see any question from any of these 4 parts. One of it is calculating molar and mass concentration. Molar and what? Mass concentration. So a student is expected to prepare his or her mind, knowing that he's going to be tested on molar or mass concentration. So the formulas of these guys, you need to know them. Is that okay? You need to know them. And then you can be tested on the aspect of calculation of percentage purity. You can be tested on the aspect of calculation of moles of water of crystallization. All right. You can also be tested on area of determining the unknown acid or base used in the experiment. So I think I've mentioned 4 aspects. During your laboratory works, you know, because when the semester started, you were going to the lab every week in order to be coached in this area. So I want to believe that by now, at least you've seen some things about it, okay? So that we wouldn't want to spend so much time explaining from the basis and everything. Like I could have maybe written formulas on the board for you first, because these are things you are meant to know. Like I said, in the GMAETS 41's physical tutorial class, there on campus in UNIZIC, we've actually treated this thing. I think that should be 2 days ago. But all the same, let's hit straight to what we are interested in doing here. So I've got this question. Please follow through as I dictate the question. And this question will cover one part in which your examiner can test you on. I want us to look at this particular exam question first, because This is one of the new things you guys encountered when you started this chemistry practical. So this is a question, follow through. I'm going to dictate, please manage the situation, making sure you copy the question as much as possible. So I read, A contains 1.272 cubic centimeter HNO3. A contains 1.272 cubic cm HNO3 in 400 cubic cm flask. In 400 cubic cm flask. That is for solution A. B is a solution of monoacidic base. B is a solution of monoacidic base prepared by dissolving 1.500 gram. Prepared by dissolving 1.500 gram of the base in 750 cubic centimeter flask. B is a solution of monoacidic base prepared by dissolving 1.500 gram of the base in 750 cubic centimeter flask. Titrate A against 25 cubic cm portions of B. Titrate A against 25 cubic cm portions of B using methyl orange. What is the molar mass of the base? That's the first question. What is the molar mass of the base? Give the IUPAC name of the base and write a balanced equation for the reaction. That's the second part of the question. Give the IUPAC name of the base and write a balanced equation for the reaction. Then in bracket, we have the following data provided in bracket. Purity of the acid. Purity of the acid equal to 70%. Purity of the acid equal to 70%. Comma. Specific gravity. Specific gravity equal to 1.42. Specific gravity equal to 1.42. Comma. Capital N, that is nitrogen, equal to 14. You are now being given their relative atomic masses. Oxygen, O equal to 16. And then hydrogen, H, equal to 1. So that's the question. Let us see how we solve this particular question. We're going to take it as question number 1 in our live section class. Now, looking at the question, we are told that 1.272 cubic centimeter of trioxonitrate 5 acid HNO3 in 400 cubic centimeter of flask is your solution A. Yeah, that's to say that A contains 1.272 cubic centimeter of that acid in 400 cubic centimeter flask. Now, that information provided, of course, once you're given all these concepts of purity of the acid, specific gravity, there is this special formula, like I said, perhaps it is when you started your laboratory work in advanced level, 100 level, that you met that formula. Now, this 1.272 is volume to be diluted. Volume diluted. Permit me to abbreviate. Volume diluted. That is volume of the acid required to be diluted is 1.272 cubic centimeter. Now, this acid, this volume is to be withdrawn and dissolved in 400 cubic centimeter of flask. That is the information provided. It's just like when you are preparing standard solution, even like WAEC and NECO, you know, all these exams that take titration exam in chemistry. They will usually send what is called white paper. We call it hint to the teacher, so that the teacher will prepare the solution for the student. So here, it's a similar kind of question. That is what is required here. In preparing the solution that is to be used for this titration, you know, the examiner withdrew 1.272 cubic centimeter of the acid HNO3 and then dissolved it in 400 cubic centimeter of flask. So you have distilled water in that 400 cubic centimeter flask. Then you add this 1.272 cubic centimeter, shake very well, and then make up to 1000. That is how you prepare standard solution. So here I'm going to have volume of solution. Volume of solution. That volume of solution is equal to volume of flask. Is equal to what? Volume of the flask. Let me indicate. Volume of flask, which has been given to us to be equal to 400 cubic centimeter in the question. Remember, your exam is theoretical, the practical. So presentation of data is very, very important. It has its own mark attached to it. Now, with this information, we can calculate something very important about this acid, which is the molarity, the molar concentration of the acid. We can calculate it. If you look at the question, actually, we are asked to find the molar mass of the base. And to get the molar mass of the base, the truth is, in calculating molar mass, there are two formulas in titration work that you use. One of the formula is that which is molar concentration equal to mass concentration divided by molar mass. You use that formula to calculate molar mass. Then the other is the formula you are going to see now, which I will use to get the concentration Ca of the acid here. Because once you are given this information and you are given the specific gravity of the acid, you know the name of the acid, which of course in this case is HNO3, triazonitrate 5 acid. You can actually calculate the molar concentration, that is molarity of the acid. Let me be fast in doing this on the board for you to see. Now, further information given about the acid is that percentage purity of the acid is equal to 70%. It was given, and then we are given the specific gravity Sg to be 1.42. 1.42. So it was given. The acid is HNO3, and the molar mass of this HNO3. I'm saying molar mass. I'm using M, capital M and small m for molar mass. If you find the molar mass of this guy, you will get 63. It's actually 1 plus 14, where the 1 is the relative atomic mass of hydrogen. It's actually meant to be given. Thank God this examiner gave this. Are you following right in brackets? But sometimes, as humans, it happens, it can be omitted. Are you following? But by standard, the relative atomic mass of these guys are meant to be given. And good enough, we have it here. But you're meant to know them anyway, for the first 20 elements at least. Nitrogen is 14, oxygen is 16. So you multiply it by the 3 atoms you have there, so that if you work out this plus this is going to give you 48. 48 plus 15 will give you 63 grams per mole. So that's molar mass of the acid. Now, why is it that we are doing all of this? The question the examiner asked us is something different. Say, find the molar mass of the base. And like I said, to calculate the molar mass, we are going to use the formula molar concentration or molarity of the base equal to mass concentration of the base divided by molar mass of the base. On this channel, I actually have wonderful video lessons that teach these concepts step by step. We're just trying to solve exam questions as you would likely encounter. So I'll be going straight a bit, okay? Now, that is the formula we are going to use in calculating molar mass. I've given it to you. The problem now is we don't know the molar concentration of the base. We don't know it. But I told you that the formula is going to be molar concentration of base. In fact, let me indicate it. I'm going to wipe it still. This problem they say we should find is we're going to solve it using molar conc of base equal to mass conc of base, and then divided by the molar mass of base. Molar mass of base. Now, to get a molar mass of base, you just make subject of formula. Now, this will go here. This molar conc of base will come down. Are you following right? So, what am I trying to say in essence here? We have this problem in this question. That to get the molar mass of the base, we need to know the value of mass conc of the base. We need to know the molar conc of the base. And these are values that were not given to us in the question. They were not given. So we have to find a way to get them. How to get them now is the most important thing we are trying to do here. Like I said, this question is crucial in case any batch meets this or something similar. Values can be changed, but the same process. Very important, because this particular stuff you're saying, I am 100% sure that to many of us is our first time of meeting it in advanced level. In O level, we don't solve problems of this kind in titration. Why doesn't even bother students about it? So you want to pay good attention. Molar mass of the base is going to be equal to mass conc of the base divided by molar conc of the base. Now we don't know this. This molar conc of the base is actually CB. So we need to know how to get CB. We need to find it. Mass conc of the base was not given, yet it was indirectly given. If you look at the question, there was this statement made in the question, said that B is a solution of monoacidic base prepared by dissolving 1.500, simply 1.5 gram of the base in 750 cubic centimeter flask. That information given that 1.5 gram of base was dissolved in 750 cubic centimeter of flask helps us to get mass concentration, because mass concentration of anything, specifically for base, is equal to mass of the base divided by volume in which the mass of the base was dissolved in. If that volume is in centimeter cube, you will multiply that guy. Let me show you. I'm going to still wipe this formula. Are you getting me right? Because we are going to walk towards it. I'm trying to show you why I need to go through some parts before getting our final answer as required. Mass conc of this base, for us to get it, is going to make use of this formula. My gosh, this ink is poured. Sorry. It's going to make use of this formula. The mass conc of base will be equal to the mass of the base, which was given as 1.5, right? And then it's going to be divided by volume of the base. Then you multiply by 1000, because the volume of the base here was given in cubic centimeter. So you see the direction we are going to take. We know this mass concentration of the base indirectly. We know it. Molar conc of the base, we don't know it. So we are going to go find it. If I get this guy, and I know this guy because values were given to us to calculate it, then my problem is as good as solved. I can now fix them into this formula and calculate molar mass of the base. The problem now is, which direction do we need to take in order to calculate the molar concentration of this base, this unknown monoacidic base? How can we get the molar concentration? To get the molar concentration, you simply use CAVA all over CBVB equal to NA all over NB, according to the information provided in this question. According to the information provided in this question, it is that cover formula CAVA over CBVB equal to NA over NB that will help us get CB. Now, you know we don't know CA directly from this question. And you know that in the cover formula, you need CA. So what we have to do is to use this information about the acid given now to calculate CA. And once I get it, my problem is solved. You see, we are not running the experiment live, for you to see the volume of acid titer value. We're simply going to make an assumption for it. Are you getting me right? We're simply going to make an assumption for it. So don't worry. If you are given live experiment to do, you run it, get your titer value. I'm sorry that I'm not going to show you or talk much about how you can actually walk around getting the titer value after running your first experiment. You don't need to run first, second, third. All those things, a waste time. We are talking exam now. We are talking exam. The first experiment you run first. The final, as in the volume of acid that changed the color, that neutralizes. You can use that volume of acid to, I'm sorry to say this, manipulate result. That is why there are some titration questions you examine alternative to practical. Your examiner can give you the titer value straight and maybe require that you construct the table. So it's not like a new thing. Even if you have to run the live experiment, because this particular question we needed to run the live experiment, you get the titer value. GMAETS is telling you just doing the experiment once is sufficient. That volume of acid that brought about the color change can guide you to know, because the titer value will be within that value. So you can use it to actually manipulate or construct a table which will give you the required titer value. So we're going to assume a titer value here. We're going to use 13.5. Supposedly, we're just going to use 13.5, okay? So I've given you this information. Now, let us go and find out this CB. And like I said, to get CB, you are going to use this formula, CAVA over CBVB equal to NA all over NB. Now look at a little challenge here now. To calculate CB, which you need to apply in this main formula that you need to use in calculating. To calculate this CB, you need CA. You need VA. VA is the title value. I told you we're going to use 13.5. You need VB, volume of base. That is volume of your pipette. Volume of your pipette. We're going to use 25 cubic centimeter for it because most labs generally use that 25 cubic centimeter. So we say we know this. We know this. Number of mole of acid and base, we know it. Are you following? This is 1:1. Thiazonitrate 5 acid is 1. The basicity of this acid is 1 because the hydrogen there is 1. If it is tetrasulfate 6, the basicity is 2. All right? And we are told that the base is monoacidic base. It's monoacidic base. Therefore, its number of moles in the expected chemical reaction is going to be 1. So these guys, we know them. We don't know CB. Now this CA, why did I say we know it? That is what we are about to do now. That's the first thing you have to do to get your CA, so you can use this formula to get CB. And once you get CB, you now apply this formula and get molar mass of the base. Remember, like I said, mass count, to get it, we have information we are going to use in getting it. Look at the formula. So I've shown you the direction you have to take to be able to solve this problem. We are going to now go step by step, okay? I'll wipe this. So first things first, let us calculate our CA. And CA, from the information given to us, we are going to use the formula. This is the formula. Volume diluted. Volume of acid to be diluted, given in the question, is equal to molarity or molar concentration times molar mass of that acid. You use this formula for acid specifically. You don't use it for base. Then times volume of solution. Volume of solution, let me abbreviate this, divided by 10 times percentage purity, then times specific gravity. This is the formula. Substitute all the necessary parameters and solve for molarity, solve for molar concentration, solve for the concentration in mole per dm cube of the acid. In fact, let me indicate this here, volume diluted of the acid. Like I said, take note, this formula is special, used whenever you are dealing with acid. Are you following, right? It's one of the formula you can use to calculate molarity, or you can use to calculate molar mass of an acid, depending on the information, the question given by the examiner. So going here, volume of this acid to be diluted is 1.272, and that's going to be equal to molarity or molar concentration. We don't know. Permit me at this point, I've given you the whole interpretation, to write this as CA. Molarity is the same as molar concentration. It is the same as concentration in mole per dm cube. It is the same as CA or CB if it is base you are talking about. And of course, there are some questions your examiner will use the word solubility. So it is still the same as solubility. So I'm using CA here times molar mass of the acid is 63, HNO3. Volume of solution into which this 1.272 is to be dissolved is 400. Divide this by 10 times percentage purity of the acid is 70% pure. And then specific gravity is 1.42. Making CA subject of the formula, we are going to get 1.272 times 10 times 70 times 1.42. We shall divide it by 63 times 400. You know, cross multiply and divide both sides by the coefficient of what you are looking for. The coefficient of our CA here is 63 and 400. So let us evaluate this and see what we are going to get. 1.272 times 10 times 70 multiplied by 1.42, and then we are going to divide this term divided by open bracket. If you want to press the denominator at once, you need to put it in bracket. Otherwise, your calculator will deceive you. Don't press this thing straight and then press divide. Press 63 times 400. Your calculator may deceive you. You press this numerator, you want to divide by a product or summation or difference of something in the denominator. Please always put that denominator in bracket. So 63 times 400. So this gives 0.050. 0.050. So the molarity Ca of the acid is 0.05. If you like, you put 0 at the back. The choice is yours. Molar. Molar. You can use capital M as a unit, molar. Or you can use mole per dm³. Or you can use mole per liter. Mole per liter. Mole per liter. These three guys are the same units for the same unit for molar concentration. Now that I've gotten my Ca, I can now proceed to obtain my Cb, which will now bring in this formula. But CaVa all over CbVb is equal to Na all over Nb. All right? I have told you already. You see, this acid is monobasic acid. The basicity of this acid here, which is the number of atoms of hydrogen in this acid, is 1. In the question, the examiner said that the base is monoacidic base. The base is what? Monoacidic base. It was mentioned in the question. Since we are told that the base is monoacidic base, it simply means that the mole ratio of the acid to base will be 1 to 1. To be 1 to 1. Take note. Sometimes the examiner will use the word monoprotic. If it is for acid, it's a monoprotic acid. But for base, monoacidic base. We also have diacidic. All right? Di means the mole ratio will be 2 in that case. So here we can substitute. We are now looking for Cb. So it implies that Ca, which we obtain to be 0.05, and then times Va. Remember, I told you we are going to use 13.5 as our titer value. So I'm going to give you an assignment. Assume titer value, construct a table so that at the end of everything, if you take the average volume of acid that neutralized this base in the process, you're going to get 13.5. Then we shall divide this by Cb, which we don't know, and multiply by Vb, which is 25, volume of your pipette, equal to 1 over 1. Solving for Cb, we're going to get that Cb is equal to cross multiply and divide by the coefficient of the unknown, 0.05 times 13.5. Cross multiply this is going to be times 1, which remains the same thing. Okay, let me even show it. Times 1. If this guy were to be 2, let's say in the case of dibasic, or are you getting me right? In the case of dibasic, for example, then you know that you're going to have Nb to be 2, so that this will be times 2. Like I've said, and I think it's clear, this is monoacidic base. The acid itself is monobasic as the basicity is 1. So we shall divide everything by 25 times 1. If you work out this, let's see what we are going to get as Cb. So this is going to be 0.05. We are multiplying by 13.5. I don't need to press times 1. It's a waste of time. You're going to get the same thing. Then divided by 25. So this gave me 0.027. 0.027 mole per dm³. That's good. I have obtained my molar concentration of the base. What is now left? Remember the formula I told you you're going to use in calculating the molar mass of this base. The formula is molar concentration of the base, also called molarity of the base, or concentration of the base in mole per dm³, or solubility of the base. These 4 words or terms, they refer to the same thing. That guy, molar concentration of that base, is going to be equal to the mass concentration of the base divided by the molar mass of the base. From there, you can now solve for molar mass. So I guess the only thing holding us now is to go and get the mass concentration of the base. We're going to get the what? Mass concentration of the base. All right. So let me see if I can squeeze up this thing here. I know that the aspect ratio of this vertical streaming does not cover much spaces. So I'm going to squeeze this thing here. Let's see. Yeah. Okay. So let us obtain the mass concentration. I was still right, but we know that mass of the base from the question is equal to 1.5 gram. And we know that volume of solution in which this 1.5 gram was dissolved is 750 cubic centimeter of flask. That was given in the question. Are you getting me right? So what do we do from here? Thank you all for joining the class and appreciating the work that is going on now. Appreciate that. And remember, like I've always said, as long as life keeps going, our God and helper continue to sustain GMAETS 41, you can always count on this channel. If you're here to subscribe to this channel, please subscribe. You can support us with whatever that is convenient for you. You can send us a super thanks. You can join the channel to become channel member. So continue to grow and assist your friends. Thank you very much for appreciating. All right, Chikwado Favor, just joining now. I'm sorry about that, but it doesn't matter. At the end of this lesson, a copy of this video is going to be made available, so you can still rewatch it. I just hope your exam is not this morning. All right. Okay, let's move on. With this information, we can calculate mass conc of the base. Mass concentration of base is now equal to, anytime you are given the mass of the base and the volume of the flask in which the base is dissolved, you can calculate the mass concentration. And mass concentration is the same as concentration in gram per dm cube. And that's what I'm trying to get here. The formula is mass of that base divided by volume of solution, divided by volume of solution or volume of flask, times 1000. Times 1000. Why are you multiplying by 1000? Because the volume of that solution was given in cubic centimeter in cm cube. It was given in cm cube. So you multiply by 1000 to convert that cm cube here to what? To dm cube. If the examiner had given you the volume of the solution in dm cube directly, there is no need multiplying by 1000. For example, like this particular question, it could have been that the examiner says that B is a solution containing 1.500 gram of the base in 0.75 dm cube or 0.75 liter of flask. If that is given, there is no need of multiplying by 1000. Take note of that. So solving for this, we are going to get 1.5. We shall divide this 1.5 by the volume provided, 750, and then multiply by 1000. Let us solve this and get the mass conc of the base. 1.5 divided by 750, or simply 1.5 times 1000, and then divided by, we have 750. If you do this, what I'm getting from here is 2. Is what? 2. Which simply means that the mass conc is 2 gram per dm cube. The mass conc is 2 gram per what? Per dm cube. Dear friends, at this point our problem is 100% solved. We are now set to calculate the molar mass of the base. I hope that you are able to follow through the journey. All right? Just imagine where the examiner dragged us from. We have to find molar mass of the base based on the information given to us. But there is no way we could have calculated the molar mass of the base straight. It's not done. Are you following, right? We have to go through all these parts. And remember, I took my time to explain why we had to go through these parts. For those that are just joining, at the end of this, please make sure you replay. Okay, a copy of this lesson will be made available. Now let us move on, please. I think at this point I might have to wipe this part of the board. Oh my gosh, I really don't want to wipe it. So that you can follow through. Let's see if I can manage this part of the board once again. Okay, just follow through. We now want to calculate the molar mass of the base. Remember, the formula for calculating molar mass of the base is going to come from that formula: molar concentration of the base equal to mass concentration of the base divided by molar mass of the base. Now from that formula, molar conc equal to mass conc over molar mass. You know, if you are writing that formula down, cross multiply, make molar mass subject to the formula, you are going to get the molar mass formula to be, now finally that's the concluding step, said molar mass, also molar mass of base will be equal to, the formula is going to be mass conc of base, mass conc of that base divided by molar conc of the base. And what is the molar conc of base? Molar conc is simply Cb. Molar concentration of the base is simply Cb, molarity of the base, which we have already calculated from here using the CAVA formula. Is that okay? Now, all we just have to do is to substitute. Molar mass will now be equal to mass concentration of the base, we got it to be 2. Molar concentration of the base, we got it to be 0.027. Now, I want to say this quickly before we land here, before we get to our final result. See, dear friends, you should not be interested in what we obtain as molar mass finally here, because it may or may not agree with any particular base. But that does not matter. Remember, the essence of this class is to put you through your likely exam question. Yes, there are some people, there are some students, some batch, that the exam question will be that taken from this concept of percentage purity and specific gravity usage. So you follow the pattern if the question is presented in this format. The volume of the acid, remember, we assumed it to be 13.5. So if you had to run this experiment live, it's possible that the titer value may not be 13.5. But do you need to be worried? No. In the lab, the solution will be provided. As you run it, you definitely get the expected value of VA. If you are careful in running the experiment, like I said, the first experiment is sufficient for you to know what the titer value is going to be like. So don't panic for whatever we get here, because I don't know what the value of the molar mass is going to be yet. Does that make sense? The most important thing here is the procedure used in solving this question. Divide 2 by 0.027. 2 divided by 0.027. From here, this gives me 74. This gives me what? 74. 74 grams per mole. That's what I got here. 74 grams per mole. You see what I'm talking about? I know very well 100% for this question. Are you getting me right? For this question, I know with confidence 100% that the molar mass will not be 74 grams per mole. Now we are told that the base is monoacidic base. The truth of the matter is, my suspicion is they're about potassium hydroxide or sodium hydroxide, as the case might be. Are you following right? Yeah, because these are the major monoacidic bases that we use. Are you getting me right? So don't bother yourself here. Don't. I could manipulate the titer value actually to get the expected value. If, for example, I say that this thing is potassium hydroxide, let me assume. Because the truth of the matter is I'm going to assume it to be potassium hydroxide. Potassium hydroxide is the only monoacidic base whose molar mass is close to this. For potassium hydroxide, the molar mass, I think, is 56 grams per mole. And that's what I'm going to assume. Me, I don't tell you my reason. If we had set up the experimental work, the solution prepared, and I carry out the experiment, you would see that the VA we are going to get will not be 13.5. It will not. And I decide not to mention anything. Work on it. Don't have any ready-made answer from outside before you go into the exam. Or don't do that, please, dear friends. You can do this thing very well. Like I said, even if you don't want to run all the experiment, which the truth is, it's not absolutely necessary. You can carry out the experiment once, but be very careful in that your first experiment, so that you can determine when the color changes and take the accurate reading of the volume of acid that changed that color. Are you getting me right? That volume you are going to get, your titer value will definitely be around it. So with that first experiment, you really don't need to punish yourself doing second and third. Yes, we are talking exam here. You can use that volume of acid that neutralized just in the first distance to construct your table and get a range of volume of acid used VA with respect to that. Is that okay? I have a video lesson that explains how you can construct your table if you have a suspected titer value already. But like I say, let your suspected titer value not be anything you see from outside. Not even what I'm doing on the board here. VA, please, please, please. You see this VA? Very, very crucial whenever you're dealing with titration. If you don't get it, you're in trouble. And you can't get it from outside. Because nobody told you that the solution or whatever anybody did from outside is the same solution your examiner is going to provide. As a matter of fact, inside the exam hall, don't ask any other person of his titer value. They might provide you people with different solutions. But what I mean by different solutions is different concentrations of solution. It might be the same acid and base, but maybe with different concentrations. It's possible. Just make sure you work judiciously with your own. You can do the experiment once and then you finish up. All right, so we are done with this, and this would be my molar mass. This would be my molar mass. Like I said, even if in the exam hall, right, it happens. Let me just assume, because there's something about practical I want to tell you, friends, now, and I hope that the lab technologists are also aware of this, so that when they are marking students' paper, they want to bear this in mind. It is not all about the final answer, the final answer, the final answer. It's really about the steps the students follow that determine scores that the students will get in the exam. Yeah, to a large extent. Because there are several factors that can alter this, your VA. Sometimes it could be that the reagents were not properly prepared. Other times it could be that the reagents have not completely ionized before they were presented to the student. Other times something just, can happen that can alter this value VA. Human errors, even from the lab technologies, can happen. I'm sorry that I have to say that, but of course I think all of us have to understand that nobody is an island. Human error from the lab technologies also can affect the solution they provide you guys, such that it can affect your VA value. And once that VA value is affected, it will affect all the answers you are getting in a way. But like I said, that shouldn't be much of a problem. Now, in conclusion here, this is what I'm going to do. I have gotten 74 grams per mole. Are you following, right? The monoacidic base, whose molar mass is closest to this 74, is potassium hydroxide. So if I were to be an examiner and this is actually what I got, I wouldn't bother. I'll just simply write below here that this molar mass is approximately close to that of potassium hydroxide as a monoacidic base. I want to believe that the lab technology is saying that should be able to reason in the right direction. Yeah, because like I said, anything could have happened to this VA in the process, which could be student fault or even lab technologist's fault. So that no one would know. For you to understand what I'm talking about, I can tell you directly that even during your laboratory works, there were certain errors and other things that you don't even know where it came from. Yeah. They tell you just do. The whole idea was just for you to get to know how this is being done. All right. I think I can wipe this. Please take a final look at it as I wipe it. All right. I want to assume you are done looking at this on the board. So I am going to wipe so we can conclude other things they asked us to do here. All right, still on that question 1. Having calculated the molar mass, the examiner said you should name the base. You should name the base. And like I said, with this I'll make this conclusion. The base is potassium hydroxide, since the molar mass obtained is closer to its molar mass. But like I said, don't panic. This shouldn't be a problem. I think I've made it very clear, right? When you run the experiment live, you are going to see that the VA will give you something that definitely would tend to what the molar mass of that base is meant to be. Okay? Have that confidence. I'm telling you this with 100% assurance. Except otherwise, if the solution given to you, there is a problem with it, which is no longer your fault. And when that happens, that is why you have to write something like this for the examiner. All right, so having gotten this, we can now conclude. We are asked to write a balanced chemical reaction equation for this reaction. So this is the balanced chemical reaction. This is a neutralization reaction between potassium hydroxide and HNO3. That is triazonitrate 5 acid. This is what's going to happen during the reaction. This guy will split here. There's going to be a bond cleavage there. There will be a cleavage here. This potassium is positive. OH is negative. Hydrogen here is positive ion, the valency. NO3 is -1, the valency. Are you following the oxidation number? So, you know what happens? Like charges repel, opposite charges attract. So this hydrogen is going to pick this OH, you get water. Potassium will pick this NO3, you get potassium triazonitrate 5, which of course is the salt, then plus H2O, liquid. So this is what you're expected to do in this work. And of course, we are able to do this particular thing safely. All right, there's a question here from one of you. If it's in mil, you still multiply by 1000, as mil is equal to cubic centimeter. Okay, I don't think there is a question. It seems like the friend is responding to someone, and that is okay, that's commendable. So you see, that thing we did about cm cube and milliliter, they are the same thing. Are you following, right? So if the examiner, instead of telling you 750 cm cube, you see 750 milliliter. That milliliter and cm cube are the same thing. So you are still meant to multiply by 1000. I hope you learned something from this, right? That's good. Make sure you stick around. All right, stick around. If you are here to subscribe to this channel, subscribe to it, turn on the notification bell so as to follow the update, because I'll still run another live section class on other forms of questions. This is just one out of the 3-4 different kind of questions that batches will be seen. Are you getting me right? As you go in for your examination. For your salt analysis, I already have 2 video lessons specifically dedicated to this. They are pre-recorded, which I've shared to various groups, okay, in Unizik, and I also appeal to you friends to share it to your friends. All right, if you slide through into GMAETS 41's Chem 107 playlist, you will see these 2 videos. One that explains everything about the test, observation, and inference of cations, and then the other that explains the test, observation, and inference of anions. So you can work on that, okay? Take the video lesson. with respect to that part of your salt analysis. Thank you for joining the class. All right, there is a question here. How do we know the base name after getting the molar mass? Yeah, this is where your own personal knowledge of chemistry comes into play. But let me assist a little here, okay? I am pretty sure to 90% confidence, that the basis that will be given to you in your laboratory work, if it is said to be monoacidic base, the base would either be sodium hydroxide or potassium hydroxide. Now, the molar mass of sodium hydroxide is 40 grams per mole. The molar mass of sodium hydroxide is 40 grams per mole. Molar mass of potassium hydroxide is 56 grams per mole. These are the two major monoacidic bases used for titration experiment. But then you can also be given a particular base, all right? That's actually a salt, but the solution is basic, which is sodium trioxocarbonate 4. Can be given this guy. Are you following, right? Sodium trioxocarbonate 4. And this guy, this thing is 106 grams per mole. Right? Yeah, this is not monoacidic base. That is why I didn't suspect it when I got 74. But again, if you do 74 minus 56 and 106 minus 56, you will agree with me that 74 is closer to 56 than 106 is closer to 56. That is why here I concluded that this monoacidic base is meant to be potassium hydroxide. So I think what I've done for you here, you have to cram this. Yeah, memorize them. If a question like this is given from monoacidic base, the base will be within sodium hydroxide or potassium hydroxide. So whatever you get, if the value is closer to any one of these, then you assume it to be the base. Remember what I said. You may not, let me not say can, you may not be able to get 100%, accurately the molar mass as it could be exactly. If you get it, kudos, right? Kudos, that's good. It's not as if one cannot get it. You really can. But there are things that can affect it, which I've told you one of the major things that can affect it is the VA value, titer value. So that is why at times, if you don't get the exact value of what the molar mass of that substance is, you get something close to it. And the rule is, if you get something close to it, please assume it to be that base that is closer to the value you got. Like in my own 74, monoacidic base, sodium hydroxide, potassium hydroxide, this 56 is the one that is closer to that 74. This guy is diacidic base, right? Yeah, supposedly it's used as a base for titration experiment. So it's diacidic. All right. So Esther Onyako, I hope I've been able to answer your question. All right. Maybe can they ask the question without stating whether the base is monobasic, that's monobase or dibase? That is to say, can they ask you the question without telling you that the acid or the base is monoacidic or diacidic? All right. The truth is, they can't tell you that. For questions like this, they can't give you a question without identifying that it is monoacidic or diacidic. The reason why they wouldn't do that is, if they do it, then you cannot get your NA/NB value. You can't. You can't. Are you getting me right? You can't. If it is the acid that is unknown, if it is the acid that is unknown, because in this case it is the base, you will hear something like either monoprotic acid or diprotic acid, as the case might be. Some of you saw something like that in your laboratory work when you were being taught. All right, guys. Like I said, I have to go now. I need to attend to other classes. Of course, I have my job class to take now. And you can learn more about the services of the GMAETS 41 on a channel here. I talk about them, okay? And I will still be back much later, hopefully towards evening. Like I said, subscribe to this channel, turn on the notification bell, very important, because I may not really be able to reach all of you to tell you, okay, the live class is about to start, but there are still other questions we are going to treat. Are you following, right? And any one of you who is able can connect anytime. So to be able to get a notification once the class kicks off, you have to turn on your notification bell. Please, subscription is free of charge, at least. Turning on the notification bell is also free of charge. You don't pay anything for that. So you have to do that for your own good. And but please, you can support this channel, okay? I've talked about that. Click on the join tab and you can support GMAETS 41 with whatever that is convenient for you. If you want to get more of our lessons, to get more benefit from this channel, you can support us with the with the platinum or diamond level. I will really be grateful, and God will continue to bless you for supporting GMAETS 41's growth. I love you guys. I love you guys. You want to be always assured of that. I'll be seeing you later in the evening with another set of questions. Is that okay? With another set of questions, but those ones are simpler. Those ones are simpler. They are easier than this. Yeah, they're simpler than this. It's okay, guys, to have a lovely time. Those that are going in for their exam this morning, maybe some persons are already in, be confident in yourself, especially if you'll be following GMAETS 41's uploading classes. You are going there to splash your A's, to come out with that A splashes, because that's what the GMAETS 41's followers and students are known for. Nothing is going to stop you from that, okay? Our God and helper, Jehovah, is going to be with you, and you have done your best. What's more? Go in there and get me the A. Be confident in yourself. Don't be interested in whatever any other person is doing. This should be your examination. Go along with what you've been taught. Go along with what you've studied all this while, with what you've known. Your examiner has nowhere to dribble you to. I wish you the very best. Success in your examinations, please. That really reminds me of something still, okay? For all of you that perhaps are not aware that GMAETS 41 runs physical tutorial on campus in Unizik specifically, okay? Besides our online class, please be aware that I run physical tutorials on campus in Unizik. And though this semester is over, you still have second semester to identify with the GMAETS 41. And of course, you'll be glad that you did, okay? Thank you once again.